Let us do some more examples on finding the arc length. Okay, this example is taken from the book section 7.4, question number 16. What it says is find the arc length of the function y equals to natural log of cosine x in the interval 0 to pi over 2. Okay, so what is the formula for the arc length? L equals to, you have a to b, and then what is the formula? Under the root 1 plus y prime square and then dx, right? That's what you do, right? So a and b are 0 and pi over 3, so you need to find out y prime. So what is y prime here? So y prime is it is natural log of u, right? It's like natural log of u. What is the formula for the derivative of natural log of u? 1 over u times the u prime. What is the derivative of cosine x? Negative sine x, right? What is that? U is basically cosine x. You see that will be cosine x. So 1 over cosine of x, because we denote that cosine x is like u, so the derivative is 1 over u times u prime. So basically you got negative tangent x, right? Now let us plug in that. Therefore L is equal to a, so a is 0 and then b is pi over 3, right? Under the root 1 plus, so negative tangent x square, right? And then dx. What do you get? That is 0 to pi over 3, right? How much is that? 1 plus tangent square x. What is 1 plus tangent square x? That is under the root secant square x, right? But root under secant square x is same as 0 to pi over 3 secant x dx. Now what is the integral of secant x? We know that, right? It is natural log of secant x plus tangent x and then plus c, but you don't need plus c because it is 0 to pi over 3. Okay, so how much would that be? That would be natural log of secant, you plug in pi over 3 for the secant x and then tangent x, and then minus you do, so you do like natural log of, right, secant pi over 3 is how much? Secant pi over 3 is 1 over cosine pi over 3. Cosine pi over 3 is 1/2, so that will be 2 plus, what is tangent pi over 3? Tangent pi over 3 is that root 3? Root 3, right? And minus, let's plug in 0. So what do you get? If you plug in 0, you get natural log of secant 0 is 1 plus tangent 0 is 0. So natural log of 1 will be 0. So that will be minus 0. Okay, so that is basically, since this is a positive number, so you don't need the absolute value. Natural log of 2 plus root 3, you can write parenthesis here because that is a positive number. Okay, so if you use calculator to find out how much would that be, that is 1.32. That's what I got from the calculator. Okay, so basically the idea is exactly the same. You just use the formula to find out the derivative, okay, and then just plug into the formula of the arc length. All right, so let us do another problem. So I'm going to do question number 19. Okay guys, let us do question number 19. So but here it is x is function of y. Okay, x is function of y. So what is the formula to find out that then? So L will be what? L will be c to d, that is c and d are the limits for y, and under the root you do 1 plus x prime square and then dy, right? That's the formula if the function is function of y. Okay, so you want to find out dx over dy here, that is x prime, and then you will plug in here. Okay guys, all right, so what is y prime? Let us use different colored, what is x prime? Oops. So x prime is basically, let me find out x prime. So x prime is equals to 1/3. It is like u to the n half, u to the n, right? What is the formula for u to the n? It is like n u n minus 1 times u prime, that will be 2y, because we are finding x prime is dx over dy. Okay, that's what x prime is. We are finding with respect to y. So what do you get? That is 3/2, right? So what do you get here? You got 3 and 3 cancel out, that 2 and 2 cancel out. What is left there is you got basically equals to, so you get y squared plus 2 to the 1/2 times y. That's what you get, right? So now let us plug in into the formula. Okay, what do you get? L is equals to C is 0, D is 4, right? Under the root square of this 1 plus square of this will be y square times y square plus 2 only, because square of y is y square. Square of the root, this is basically root, right? Is just that one, and then dy. Okay, so let us simplify that. What do you get? 0 to 4, right? And then under the root, what do you get there? You will get y to the 4 plus 2y square plus 1, and then dy. Can you complete the square and then write without the square root here? Let me write down that. It can be written as y square plus 1 and then square and then dy, right? That's what you get. You got that? So that square and then this square and then this root will cancel out, right? So what is left is basically 0 to 4 and then y square plus 1. Now you do the integration, because it is free from square root, right? What is the integral of that? You got y cubed over 3 and then plus y and then 0 to 4. Let's plug in 4 first. It will be 64 over 3 plus 4, right? And then minus, plug in 0, that will give you 0 basically. What is 64 over 3 plus 4 is 12 over 3. So what is 64 plus 12 will be 76 over 3. Okay, so you can use calculator to find out the decimal value, but that's what it looks like. Okay guys, all right, let us do another problem. So here because you know some of the integral, they are very hard to find out, or we cannot find out manually, so we use the numerical techniques. Okay, like calculator or the computer software, they also use the numerical techniques. So here on number 24 and 26 from the book, we are not using the techniques that we use here, okay, because they are very complicated to do that. So what we do is we use the numerical techniques. That means we use calculator to find out the integral. Okay, so but we first set up the integral though. Okay, all right, let us do that. So what is the formula? Formula is L equals, so this is y is function of x, so it will be like a to b under the root 1 plus y prime square and then dx, right? That's what you do. But what is y prime though? So let's find out y prime. So y prime, because this is like, if you move this to the top, this is what you get, x plus 1 to the negative 1, and then we are finding the prime of that, derivative of that, right? What do you get? That will be negative 1 x plus 1 to the negative 2 times the derivative of the inside is just 1, right? So this basically you get negative 1 over x plus 1 to the square, that is y prime. Okay, now if you find out, so if you find out the if you plug in this in your calculator, then what do you get? You get L equals to that arc length. L equals to, L will be given as 0 to 1, right? Under the root 1 plus, what is the square of this? Square of this will be 1 over x plus 1 to the 4th and then dx. Okay, so it is very complicated to do manually. So what you do is you just press math, okay, and then go to integral. Let me make sure that I'm telling you the right thing. Okay, so math and then go to the fn integral. Okay, that's what it says, fn and then integral. And if you press that, it will give you, fn integral will give you like the you will see these kind of things. Okay, you will see these kind of things, a box here, a box here, a box to enter the function, and then d and then box here for the TI-84. TI-83 you will see the similar thing. So you just plug in 0 here, 1 here, and then that function under the root here, and then dx. If you do that, then your value will be approximately, that's what you will get, 1.13. that's what you will get. Okay, if you do that. Similarly for question number 26, you do the similar technique. Okay, so what is y prime? So y prime is equals to negative sine x, right? Yeah, negative sine x, right? So so that will give you what? That will give you that will give you the L is equals to negative pi half to pi half. I'm using the exactly same technique, right? 1 plus sine squared x, right? Because the square of y prime will be square of that thing, that will be basically sine squared x dx. Again, this problem will be very complicated, okay, if you try to do by hand. That's why you do the same technique, just use calculator to find out that, and you will basically get almost 3.82, okay, if you enter that in your calculator. Okay, so some of the integral, they are very hard to calculate exactly by hand. That's why we use the numerical approximation, okay, numerical method to solve it. So numerical value, most of the time they give almost the same value. Sometimes it may be a little off, but the numerical method gives you very close value to the one that you do manually. Okay guys, that is all about finding the arc length. In the next video, I'll discuss about how do you find out the surface area using the integral. Okay guys, all right, thank you.